for those of you who haven't been before, although I think possibly most of you have, not sure, we are Rust and Cpp Cardiff. Me and Alex help organize it, and there are other organizers, but they haven't been able to make it today. And we've been doing these book club sessions to get folks up to speed, including us, on Rust. We have a Twitter and an email and a Discord. The Discord, we chat a bit about the chapters in between. I think as the chapters get more beefy, there'll probably be more chat. But yeah, our objectives are to learn and share, introduce new people, challenge ourselves, and once we actually start writing some beefier code, real world solutions, and just generally advancing our ability. Several of us work for Esri, so they sponsor the Meetup page, which is how we're able to exist. And we have a code of conduct, which is just the Rust code of conduct, which is just be good. And the Pac-Man rule just means, yeah, let people join in your group discussions so that we can welcome new people. Yeah, this is the book club. Brief recap on last week. We covered the Rust toolchain first week, just doing the introduction and hello world, and then week 2 is when we started actually getting into the language. I want to do a quick check of where people got up to. So I'm going to launch the poll. Hopefully that'll come up for you, just to check where folks are at so we know how fast to go. Okay, cool. So give you a couple more seconds. Okay, so it looks like some people everyone's got the toolchain set up on their machine, which is the most important thing. And some people have been through the chapters and we've gone beyond chapter 6. And we have one new person. Welcome, new person. So that gives an idea of the kind of pace to go at. This chapter is quite a good one to, I think, start getting into if you've not done a huge amount of Rust, because it really does start to introduce you to some of the structure of the language. And there's a recording from last week's meetup, but there's also the Discord. So if you have any questions, whoever you are, then just ping on there and let us know. I'm going to do this the same structure as last week, where I've just created some slides summarizing it, but it's an open discussion. So just jump in at any point with comments, questions, discussion points. Yeah, last week we covered basic programming concepts, types, control flow, mutability, understanding ownership. The understanding ownership was quite a fun one. We'll kind of probably touch on that again many times over the next few weeks. So on to chapter 5, using structs to structure related data. Split into 3 sections. And the first one was defining and instantiating struct. So it's just the basic syntax. We've been through tuples already. The main difference is that these are named, don't rely on order, and you use the struct keyword. But other than that, very similar. This is what it looks like when you create one. And so that's you defining one, and then that's creating an instance of it. And you can see the order doesn't matter. So here the order's different. They've got active at the bottom, so near the bottom versus active at the top. And there's this shorthand notation, which me and Alex were talking about before this meetup. It's quite nice. And I think as well, it's useful to know that it's there, because if you're reading code and you don't know that exists, I would have probably found it quite strange and been a bit confused. So it's, yeah, if you've got the name, if you've got the names the same, then it means that you don't have to write username : username. It will just figure it out for you, which is nice. You can also create a new instance of a struct from an existing struct. In this case, it's just like assignment. So we're in this line here where we're doing user2 equals user ... user1. What that means is you're pulling all of the data fields out of user1, and then you're copying them into user2, which is just like assignment that we did last week in terms of ownership. So all the same ownership rules apply. And since in this case, string doesn't implement the copy trait, it means that the user1 reference is actually now invalid, because we've pulled out the username and the email and those were don't implement the copy trait, which means we don't have ownership of it anymore. This is saying exactly the same thing. So reference user one are only still valid if all fields used in the user type implement the copy trait, and that's because this is doing it field-wise. One thing I wanted to add in, which I don't think was in this chapter, but is important to mention, which is that the user type doesn't need to implement the copy trait for this syntax, but this syntax does. So for this syntax, even if every component implements the copy trait, if you haven't declared that, if you haven't implemented the copy trait on your user type itself, then it wouldn't work. So it's just, I thought it was kind of necessary to mention that. I don't know if anyone else thought that when they got to this bit and thought it was worth a mention.
I was about to ask you why you would use one rather than the other. So you precisely answered my question.
Yeah, that's one reason, and also being able to just pick out parts. So the example, in the example, this is me showing an error case, but in the example, you can say, take out the username and then copy everything else. So that way you could copy everything apart from one of the fields or two of the fields, and it will just fill in the gaps. So anything that you haven't copied from the other user, it'll copy in, which is quite nice. I put this slide in here because this will error. And I just wanted to highlight that. So you've created your instance of user struct 1. Then you've created an instance of user 2. So again, this is the ownership thing where now, even though I've created a new string for the username of user 2, I haven't done it for email. And as a result, because not everything that I've used implements the copy trait, it's moved ownership of the email string into user 2, which means user 1 is no longer valid. Which means that this function, print user active, which takes a user by reference, doesn't work, even though I'm only using the active field within user. But you can still access it within that scope. So it's like quite smart, but not super smart. So even though after you've done this, the reference to user 1 as an entirety is invalid, user1.active is still valid because that one does implement the copy trait, so you can still use it. And I just thought that was it's kind of a subtle distinction that you can't pass the user by reference anymore, even though some of its fields are valid. You can only pass by reference if all of its fields are still valid by the looks of it. I thought that was worth mentioning. It gives you a really clear error. So value borrowed after partial move. Partial move occurs because one.email has type string, which does not implement the copy trait. So yeah, you can no longer borrow it, which is worth a mention, but you can still borrow the valid parts. So this is, again, that distinction. So here I'm passing in a reference to a bool, and even though I'm passing in user 1's bool, because that part is still valid, I can still pass it in. So can't borrow the full user, but I can borrow user.active.
Presumably, Ciara, if you did want to implement the copy trait for your user class, you would do that, and when it came to the string fields, you would clone those 2 string fields so that you had a new instance of them.
I don't believe that would be possible. So I guess you can't automatically implement the copy trait because you can't implement the copy trait on anything.
You have to do it manually. You have to write what you want to happen to various members.
Yeah, and there's a risk with that because you want to know that you're doing a clone. That's one thing I do like about Rust is it doesn't hide. It uses the clone word when it's doing a clone, so it's very clear. And I would say in those cases, you'd probably want to make it just have a separate method that is called clone.
Have a user clone method.
Exactly, and because clone of copyable types is free anyway, pretty much. So just using the clone keyword is probably a clearer way of saying what you're doing. I don't know.
Just a little question about this, just to see how clever it actually is. So say I had a situation where I was cloning using this method in the code example here, and say everything that I'm not explicitly setting was copyable. So the only things that I'm interested in copying from user 1 implemented the copyable trait, and I was manually defining the other variables. Would the compiler be clever enough to know that that's what I'm doing and then leave user 1 as a valid reference? Or is it taking an all or nothing approach?
So in Ciara's example, if you'd taken the email, I suppose, yeah, you want to clone the email, don't you? You want to clone the username and the email.
Yes.
Yeah. So if you'd done clone here, then it would be fine. So for example, that's the equivalent of I think actually I did that. I created new strings for both username and email, and then it does allow you to then still use user 1.
Right.
Because you haven't done a partial move then, which is the bit that's the problem, is that partial move.
Right. Okay. Cool. Thank you.
Which brings us then on to tuple structs, which have no names associated with their fields. But you can still, for example, implement things on it, implement traits on it, which doesn't have names for its fields. But it does mean, so the reason you would use this over a tuple is because it's strictly typed. So you won't get them muddled up, which is convenient. They use the example of color and point, which was 101 other examples where you've got a couple of numbers knocking about and they could be anything. So it's a nice one to have. There's also unit-like structs, which I would have quite liked them to have put some examples in for this. Obviously, they've used this always equal example and said you can implement traits on it, and therefore it's useful. But I probably would have liked to have seen some examples. I don't know if anyone knows of any examples of these unit structs.
Off the top of my head, I've come across it for functions that don't return a value, so that they return a void, but they might error. And so they want to return a result package, but they're not going to have a value part of it. They're only going to have an error part of it. So they either succeed, but there's no value, or they have an error. So I've seen it being used in that situation.
Could you use a result with a unit type then?
Yeah, exactly. So it'd be a result with a unit type to give you, to let you know
clearer, I suppose.
Things have succeeded. There's no information for you to get from it succeeding, but you know it hasn't errored. Or you can look at the error.
Okay, that makes some sense. I can believe that.
I'm sure there are other places it's used.
Yeah, so am I. And I can see it being used for like maybe grouping together functions, for example, by having them all, instead of using a namespace, you just use a unit struct and then implement a load of functions on it. The next section is 5.2, an example program using structs. It starts with talking about rectangle, which is a classic. This is the example that they use. It's fairly straightforward. It declares a struct, creates an instance of it, and then prints the area. And it has an area function, which can take the type by reference and return unsigned 32-bit integer. It's a reference call so that the caller maintains ownership. Now, this is just a standalone function that takes a rectangle. And the reason it shows you this is so that it can then move on to talk about member functions. But first of all, it talks about the debug trait. The debug trait is what allows you to print using this pretty print syntax. Actually, this isn't the pretty print, to use the debug print syntax. You can either implement it manually or you can derive it, which is probably the more common way of doing it. And it allows you to print using that syntax. And there's also pretty print, which is declared, and it will kind of space it out and make it look like this, which is quite nice. I was kind of curious. I don't know whether anyone else dug into this. I didn't properly dig into it. I think we'll get to it later. But what derive is actually doing, it's quite, it's nice that these things work. I love that they work, but I don't fully understand it yet. I found out these are procedural macros, which we'll get to in chapter 19, which operates on Rust syntax and generates new code, as opposed to the other type of macro, whose name escapes me, the simple kind, which I do fairly basic find and replace. I found that you could do this expand macro, which is quite useful if you ever are not sure what a macro is doing, but you need to be using the nightly Rust compiler So you say Rust compiler, unpretty expand, and you point it at the source file. And so for this one, it shows you then what gets dumped out. So it's implementing core format debug for rectangle, taking self by reference, formatter, doing some stuff, voila. It's something I think we'll get to probably later, but you can write your own ones of these and they're super powerful. So they're pretty cool.
Yeah, so you can imagine that macro language has allowed you to loop through the members of the structure it could see. Was that all the output? What I was interested in was whether the hash derive would use its meta programming to generate the print statement, but whether it, because it goes on, it still declares the struct, obviously, for the rest of your program to use.
Yeah.
There's one sort of half expect the macro to do its work and then dump the struct in the code after it so that other people can use it or before.
So debug doesn't do the print itself. It uses the formatter, and it's not just used for printing either. In terms of how this is actually working, I wouldn't like to say exactly. It's returning a format result, and that's the bit that then does the printing. So it's a how exactly all of this works, I'm not 100%, but it's building it up to then return this format result, and it's that gets printed. So then it's a print statement that's what does the printing. So if let's give an example, because you can also use it for debugging. What's quite cool about it compared to the regular formatter is that you can just slip it in line and do it wherever you want, which I think is quite nice. Rather than faffing around having a line before checking the value, and then you can just litter your code with it while you're figuring stuff out and then go through and rip them all out, and it won't change anything because it just outputs the input value. Quite nice. Section 5.3 is method syntax. This is as opposed to those standalone functions that took a rectangle as a parameter. These are the equivalent of member functions, but they seem to call them methods. Take your term if you like it. Defined within the context of a struct and takes self as the first parameter. And the way you do that is you use an implementation block. So for example, here we're taking rectangle by reference and then returning the area. And you don't have to take it by reference. You can take it by value if you want, but then you'll have invalidated any reference to that struct because you've taken ownership for it. So unless you returned it back out, you wouldn't still have it. Ref self is short for self : type reference, capital S self, where self is just an alias for whatever the type was that the implementation block was for. And similarly, as I said, you can take it by value, and you can also take a mutable reference if you want to change the values inside it. Beyond that, it seems quite similar to just member functions in other languages. It does do some automatic referencing and dereferencing to make things a bit nicer. I think similarly, they do this in other languages. But here, if you're taking P1 by reference, rather than having to write ref P1, it will automatically do that for you. So you don't need to write anything extra compared to when you're taking a reference versus value versus mutable reference. You don't need to think about that. It just does it for you. There are also associated functions, which just don't take the instance. So they don't take self. The example they give is a constructor type thing. They don't seem to have constructors. But again, it's this idea that then we're returning a new instance of rectangle. In this case, it's creating a square rectangle by saying let square equal rectangle square 3. So these are like static functions. They avoid that word anywhere, which is fine. I guess it's obvious that it is because it doesn't take itself. So you don't need to have an extra keyword for it. So to summarize the structs there, group related data, you can implement traits. Some of them are automatic, like derive debug. And then we can define the behavior in an implementation block, which take the self instance. And then you also have associated functions, which in C++ we call static. Don't know if anyone else had any comments on that chapter. That was everything I could think of about struct.
The only other weird thing I saw was where you could have multiple impl structs and they kind of all combine into one thing. I'm not sure why you would have one impl of a struct and then another one elsewhere, which is a bit odd.
I think the rationale behind having multiple potentially implementation blocks for rectangle is, say you needed to implement a trait and there were multiple functions that you needed to implement in order to implement that trait. You would then be able to have that just in one block, and you could potentially put it somewhere, and then you could do the other bits somewhere else, and that way you can get a bit of separation in your code rather than having one massive implementation block.
With all the different, that makes more sense.
That's the impression I got anyway. I'm sure there are other use cases.
It feels a bit like monkey patching in Ruby and then or Python or whatever, but then you're like, ooh, obviously isn't doing that. Okay, that makes sense.
Another use that occurs to me as well is I think it might come up in a later chapter, but there's a feature of Rust called features, where you can actually it's almost like making a macro where you decide what you're actually going to compile at compile time when you pass it in as an inline argument. I guess I could foresee a situation where you'd choose which impl block you actually want to use based on some command line argument. But again, I'm thinking about this now because I'm thinking about a past project where I could have done that, but ultimately I just made two types and chose which one to use based on that. But yeah,
it's just kind of polymorphic at runtime. So you say which feature you want to kind of choose as the implementation of that as you start up. Okay.
Yes.
Yes.
Yes, compile time, not runtime.
Compile time. Yeah. Oh, sorry.
I'm just reading the comments section.
The other thing I noticed on structs before you move on, Ciara, was that you can specify some of the fields in your struct to be mutable, which then got me thinking, well, surely I want the whole struct to be mutable or not mutable. And does that work? If you've created your user with 4 fields, if I have a mutable user variable, presumably all 4 of my fields are mutable. But then I was trying to think, well, why would you want just some of your fields to be mutable? Does that mean you've got a non-mutable user, but you can mutate some of the fields?
I haven't actually played around with the different mutabilities on it. Maybe I should have done. A use case I could see, although like I say, I haven't played around with it, so it might not work exactly. But it's like a global ID, for example, for a user. If you've got some separate table, for example, that you're storing it in, or that's the thing that things get mapped against, you don't want to change that after the fact. You want that to be fixed, but everything else about it can change. So the actual data might be stored there, but then there's some key that's like, well, if this changes, you might as well create a new type because it's not the same thing anymore.
Yeah, the example I was thinking was the other way around, where you want everything to be const except for your variable where you cache a calculation result, a just-in-time cache. So what we would have had as mutable in C++.
Yeah, that makes sense as well.
But I couldn't see quite if it worked because the mutability rolls up if you I presume. So if you've got a struct containing a struct containing a struct, it seemed to suggest that if anything in there wasn't mutable, then all the higher ones wouldn't be mutable. It'll probably make. Oh, you can see some answers in the chat.
Where's the chat?
It definitely shows in the book that you can make some of the fields be non-mutable. Be mutable, which implied that some of the others weren't. I'll have to find it now. So don't let me hold it up on a detail.
Yeah, I'd need to go back over it. We can maybe come back to it at the end.
I found it by then.
So chapter 6, enums and pattern matching, goes through defining an enum, the match control flow operator, and using if-let for concise control flow. Definition of an enum is pretty straightforward. I like the example they gave of IP addresses. I think it's quite a nice one that covers a lot of stuff. So the idea that you can then tack on additional data makes a lot more sense, because you can only have, you only care about one, which type of IP address you're using, but you still might want to store it. So me and Alex were talking about this a bit beforehand. It's kind of almost sidestepping polymorphism. So rather than having multiple IP address, this is the implement from a base IP address type, which then you wouldn't really be able to switch on cleanly because you don't have some enum. This would then allow you to say, okay, if I have an IP address, I know it's only ever going to be one of these types. So I want that switching ability, that kind of quite clean lockdown nature. And then each enum variant can store different amounts of types of data. Oh, data typo. For example, here they've got it done for storing a string versus storing 4 8-bit unsigned integers. And you can define methods on enums just like you can on structs with identical syntax, pretty much. We were discussing, it's kind of then, there are a lot of similarities then between enums and structs. But I think that's probably a good thing. It's made enum super flexible, so you can do a hell of a lot with an enum in Rust compared to in other languages. I think it's probably why in the chat of the Discord, someone was saying they found the C++ talk on pattern matching a little bit disappointing, and I think it pretty partly comes down to the fact that they don't have this super powerful enum type that can do 1,001 things. So in this example, you always know that the message is going to be one of these 4 types, but each one of those messages has different associated data with it. Therefore, this one needs to have a move coord. This one needs to have the actual color. And then you can define the implementation of what actually happens when you call message, for example. And the classic example of an enum is option, which is a generic type that can take anything, and then either it has it or it doesn't. And people use it all the time because it's great. It's similar to optional in C++, but I'd say even more straightforward. T is the generic type parameter, so you can put anything you want in it. If you haven't specified, so if you want to create it with a none type, then you have to add the type annotation. So in this case, option I32, so that the compiler knows what type it is, because none obviously could be anything. There are methods. There are various methods to check enums. You can check the values with is_some or is_none. There's also an expect function so that you can get it to error if there's not a value. And that's if you always expect it to have a value, then you can't continue with your application. If it doesn't have one, then you can throw an error. There's also unwrap or, which falls back to a value if none is set, and you can use zip to combine optionals, which I thought was quite cool. I hadn't seen this before. That way you can say, okay, these all need to have values, and if any of them don't have values, then it's a none, which is quite nice. And then I scrolled through this. I just picked out those ones, but there are a lot. There's a lot of useful ones. So before you try and roll your own, there's probably one already doing what you want, like zip, for example.
So that zip, does that create a optional of a tuple?
Yes.
Yes.
I believe so. Yeah, that's what it looks like it's doing.
I think I found something really cool that was very similar. Is if you have a vector of optionals, and then you collect that to a option of a vector, it kind of combines them. It kind of unwraps them all and combines them onto one optional, a bit in the same kind of way. If that makes sense.
So if any of them aren't there, it will just create a none. It won't let you create the vector, and then
but if they're all some, then it kind of unwraps them, makes a vector, and puts it inside a sum. It's quite cool.
I like it. Some of the other ones kind of similar to what we've talked about last week, and I'm sure we'll touch on again. There's this as ref and as mutable. So you can take your option string and then you can kind of cast it to an option ref string, and that way you won't consume the string when you try and use it. So the example that they give in the doc here is saying you can still get the text after getting the length as an option usize. So you've got, I mean, it's pretty long, I'd say, the description of getting the length, but it is still, yeah, quite useful. And then as mutable, again, you go from having a mutable optional to having an option containing a mutable type. And that way, when you get in this example, so you said, okay, if I have the value, I want to change the value. You can only do that if you've actually got the mutability inside next to your t. You're not changing it from being a sum or a none, you're just changing the value inside it. So look, there's many similar things like that that allow you to propagate things safely. The match control flow operator, also very useful. It allows you to compare value against patterns. This again is similar to what we were talking about with C++ trying to implement it, something similar. And patterns can be made up of literal values, variable names, wildcards, and many, many things. One important thing to note is that matches are exhaustive. That's one of the things that makes them so useful, is you know if you've missed something. The example they give is they take an enum with a penny, nickel, dime, and quarter, and then they match on it and then return its value in cents, which is nice and straightforward. It's just an exact match there, so there's nothing too complex. Actually, one thing worth mentioning is that here, because I always get it the wrong way around, it's a expression or statement. Which way around is it? It returns the value because I'm not ending with a semicolon. So here, the U8 I'm returning, I don't need to write anything. Expression is returned. Yeah. So it's returning 1, 5, 10, or 25 without me needing extra syntax to describe that, which is nice. If it matches, then the code's executed. In this case, it's straightforward. If the pattern's not matched, then it just continues trying to find it. At first glance, it looks similar to C++ switch statement, but it's much more powerful. The C++ switch only works with integral values. It can only be used for checking equality, and it can't be used as an expression. So in that example where it's returning the values, because it's can't be returned as an expression in C++, that wouldn't work. From maybe C++ 23, maybe C++ 26, who knows? There might be an inspect statement which would allow you to do some of these things, maybe more, but we shall see.
Allow you to check against runtime values in Rust. So if you've got a string that you're using it to try and compare equality of strings or something.
Yeah, I believe so. It can do pretty much anything. It's pretty flexible. Yeah. I think there's some examples in here possibly that we'll get to. But this one is the example of matching on a range of values. So 0 or 1, 2 up to 9, 10 up to 15 inclusive, and then everything else. So this, sorry, this one's inclusive, this one's exclusive. Someone who knows their brackets can say whether or not which one's the closed and which one's the open set.
Second one is half open.
Half open. And then you've got this underscore, which we'll come on to in a second. You can also bind to parts of the match value. So in the example they give of an enum where on the quarter they store which US state is on the quarter, it's a fairly arbitrary example, you can extract the state from this match statement, and that way you can print the state, which is quite cool. It's pretty flexible. You can actually get the data out from the match. And this is, particularly useful with the option type, because that's just an enum, switching on it, and then we're saying, okay, this I is going to match something. And once I've got it, I'm going to then increment it and return some value. Oh, I just saw someone in the chat says that it is compile time. So presumably it couldn't match on a string then that's done at runtime. Interesting. There you go. It will complain if not all possible patterns are satisfied, and we can make our match exhaustive with the catch-all and placeholder match arms. Okay, so in the comment sense says also compile time if we match on constants, but if it's not constant, presumably then you wouldn't be able to match on it. compile time. We'll have to play around with it.
We'd have to do a runtime evaluation, I guess. Seal it. It does suggest that you could have all sorts on the left-hand side. You could actually have function calls on the left-hand side. Might just return true or false. And the first
do
one.
like an if thing. I've seen you can do the constant and then if and then a condition, which I guess could call a function.
But then does it have to be a compile time evaluated function? Does it have to be like a equivalent of concex but for Rust? That is the restriction on the C++ one, I think. So it would make sense for it to be there on the Rust one as well. Not sure. We'll have to tinker. It should be easy enough to test, and then we'll know. And we'll probably get a nice error message that links us to a piece of the doc in chapter 22 that tells us. Oh, cool. Someone's going to try it out on the playground. So the catch-all, in this case, we've named a catch-all called other, and then that way we can do something with it. So in the example they give, you're doing a dice roll, particular numbers mean something, and any other number, you need to do something still with that number. If with your catch-all term you don't want to do anything with it, you just don't have to give it a name. You can just put the underscore, and that will be the default, and it will catch everything else.
Is underscore actually a magic character, or is it's just an identifier that people conventionally use?
It is a magic character in that it's unused.
So
In
is
this
other.
context, like I don't think it won't bother putting a value on the stack, I wouldn't think, if you've put the underscore, whereas if you've done other, even if you're not using it on this side, it might not be clever enough to figure out that you're not using it. And in the example of, say, it being something like a string where this might be taking ownership of it, presumably then you wouldn't have ownership, would you?
So you literally couldn't use underscore as a value on the right-hand side?
No. And if you put, so another use for underscore is before a variable name to say that it's unused. So you get warnings if you've got unused variables in your code. And if you put an underscore as at the start of the name, then it's saying, I know this is unused.
Yep.
You don't need to warn me about it. But why do you have unused variables in your code? Good question. Very good question. Who knows? The next section, 6.3, concise control flow with iflet, is very similar to what we've seen so far, but it just gives you a little bit more flexibility. Well, I guess less flexibility, but it matches just one pattern and then ignores everything else. So it's saying, if it's of this form, some value, then print that line. So we're matching on config max, but we're matching just with one pattern, which is some max. And then we're getting the max out. It removes a little bit of boilerplate code, and you can also have an else statement on it. I personally find it a little bit harder to read than a switch statement. I don't know what anyone else thinks about it.
So so the sum max in there is the bit that would be at the top of the match. The config max is what would be on the left-hand side of the arrow in the match. And then the print line is what would be on the right-hand side. So yeah,
no, the other way around. So sum max is our pattern. Config max is the thing that we're matching against. So dice roll is config max.
Yeah.
3 is sum max. So it's saying if we can make sum max equal config max. So if config max matches this pattern, then we could do this. If we can do this, so we're letting sum max equal config max, then we have the max value afterwards because we've pattern matched it. So if config max matches this pattern, then we can extract the value and do something with it. And then you could also add an else statement, so else do something else. Oh, someone said, I love it. Is that referring to the if-let syntax? I'll maybe learn to love it.
It's a bit like, I guess, the newer if statements in C++ where you could put the assignment and check in the Booleanness of it inside the if statement, and then you use it. It's got things the same way around as that. So it's sort of closer to that than it is to a switch or case statement.
Question for anyone, does max exist? I guess max still exists outside of this scope. Does it? Can you still use it afterwards? You're saying it's same as normal in... Okay, so if it's not, yeah, same as normal assignment, this bit same as normal assignment, but it only exists in the context of this scope. Okay.
Yeah, similar to how it would be in an arm of a full match statement.
Makes sense. And that takes us to the end of chapter 6. They're quite similar chapters with a lot of overlap there. Quite good. Yeah. Chapter 6 is quite tight. We've got coming up chapter 7 and chapter 8. Actually, before we talk about what's coming up, does anyone have anything else we want to talk about with structs and enums? Is there anything else that came up?
I'm a bit worried that I actually dreamt the syntax I was talking about.
That would be fair. I had one thing for any C++ people in the room. I played around with the circle, where is it? The circle implementation of this inspect statement. Oh wait, is this it? Oh no, sorry, not using the inspect statement. This is just using pattern matching before you get to inspect. And I found that, I don't know why I have it printed twice. Sorry. I found that this doesn't work. I was trying to copy from the presentation without having the exact link, and I was trying to write it out, and I assumed that I could print X still. It is conspicuously missing from this list in their example, so I'm guessing that they can't do it, but I was just wondering if anyone had any thoughts on why that might be. I should probably give some context. This is from a CppCon talk. It's doing pattern matching where you're passing in template parameter by const ref. This is special new template syntax. Do not try this with your compiler at home unless you have circle. And then it's saying if I can pattern match, so similar to the syntax we had of, okay, if let something equals something. So auto I is int equals x. So we're saying let I equal x if x is an integer, then we can print I. And then there's also this one, so else if x is integral, then it's a non-int integral type because it didn't match against this one. But we can't print it because if we print it, then somehow the tuple line fails. And it fails saying that it's failed the one definition rule.
Certainly the crucial thing that's different in all the others is they got the X on the right-hand side and they're matching a new auto variable against it. That's what they're using in their print.
Mm.
So you could presumably do it if you used auto I is integral equals X and tried to print out I.
Let's try.
Like why you can't use the X when this X has been passed in. I mean, I guess this is all at compile time.
Yeah, you're right. So if I say auto I is integral equals x. So I just wonder why they had that syntax in there of is integral if it then breaks the next case for reasons unknown. But anyway.
Yeah, well, it works. You just cut so long as you don't try and use it.
Yeah. I can't quite reason about why using it would break it. Maybe because it tries to, no. No, I don't know. Anyway, I thought it was interesting to see anyway what might be coming in C++ in the future. Oh, someone in the chat has possibly, hey, this has answered your question. Maybe it's something like let some struct mutable a comma b.
It could quite possibly have been. Yeah, so that's creating an instance of a struct from your particular variables. It certainly looks like what I was thinking of. I will look it up and try and find it. Yes.
I'll have to have a tinker and play around.
Yeah, thank you for that. Yeah, Hades.
have as well. So I have a question. So I haven't someone commented this week's been kind of short. I kind of agree. Maybe we should have done 3 chapters there, but the next one is managing growing project with packages, crates, and modules, which is quite different to what we've just been doing, but also very useful because it somewhat allows you to do a bit more. So I had a question, which is, when shall we do the next session? Oh, Tim Heaney's put a good comment. So taken together, structs and enums make Rust types algebraic. In mathematics, they are products and co-products. In computer science, they are product types and sum types. So presumably you're saying there a struct would be the product type and then enum would be the sum type. Potentially.
Yep.
Mm.
So it's like with structs, you've got all the values simultaneous, you've got all the members simultaneously, and they can all take their full range of values. So if you imagine the full space a struct could occupy, it would be the Cartesian product of all the types that make it up. Whereas for the enum, you can only have one of the options. So it's more like an OR.
Mm.
Which in probability, you get your OR by adding probabilities together.
Yes, it's a nice set of 2 chapters, and it gives us a lot of, it shows you a lot of the syntax that you see all the time in Rust, because match statements are just so prolific and they're just absolutely everywhere. So they're very useful to get a handle on quite early. Especially here, we've just talked about the option type. Did we even mention the error type? Possibly not, but that's another one that you'll see all the time. And then as soon as you start returning options and result types from things, you've then got to immediately start using these unwrapping syntax and switching on results. Okay, it seems like 2 weeks is still a winner. So let's then do the next one. So the next chapters are managing growing projects with packages, crates, and modules, which is a decent size, and it's quite different to the other ones, and it's more to do with the project structure, but it's still a very important one. Common collections covers more information about strings as well as things like maps. Again, super useful. All the chapters are useful. And then the one after that is error handling, which we could cover if we want to cover 3 chapters. The nice thing about doing 3 chapters next week is that it would mean we could potentially dedicate in a whole week to generic types, traits, and lifetimes, which is a bit chunkier. But equally, we could cover that. We could cover error handling just quickly before we get into the generic types, traits. So it just depends how people want to stack up their weeks. So I'm going to put a poll out for how many chapters we want to cover next session, given that it's going to be in 2 weeks, which is Thursday the 25th. I can't vote in the poll, but that's probably for the best because I don't have any strong preference, I don't think. Okay. So most people have gone for 7 and 8, and we've got an equal split between less and more. So that seems like also a good compromise in that respect. I think we should comfortably have enough time to cover both of those. And it'll be nice to see some of the growing projects stuff, because that's what allows you to then get stuck in and start building something yourself with any scale rather than just toy code in one file, which is quite nice. Final question. How long? I don't know how people feel about the sessions. We've been sticking pretty well to an hour. This one's obviously been slightly shorter because it's fairly tight content. This week there wasn't too many offshoots, but there might be in the future. I imagine there'll potentially be slightly denser content with more discussion. So I just want to check how everyone feels about the length at the minute, what they want going forwards, and we can switch it up anytime as well. Okay, seems to be most people happy with an hour still. I'm happy with as well. It's quite a nice length. It's not so long that you have to dedicate your entire evening to it, but we still cover quite a lot. And if you've covered the chapters beforehand, then it's just a quite nice recap, I think. There's the other question, which I didn't put in here. That's kind of more of an out loud one anyway. Is does anyone want to take the lead on managing growing projects and common collections, or either or? You don't have to say right now, but if anyone does want to do the kind of leading through the content, then yeah, just let me know, and then
I'm afraid I have a conflict in 2 weeks, so I'm not going to be able to make the next session anyway.
Oh no.
So I'm very sorry about that.
I didn't do an entry on does this day still work for everyone. I maybe should have done that.
It's just a one-off.
Okay. We'll record it anyway, so you can catch up. And actually, you've done some decent sized Rust projects, so you've played around a fair bit, and you've published a crate, so you already know all this stuff. It would have been good to have in the conversations, but
it's quite a well-written chapter, so yeah, it should be good. Enjoy reading it, talking about it.
Thank you. All right, I think that's probably the end of the main meetup. People are welcome to stay and chat if they want on anything. I'll stop the recording now.